All right. So yeah, let's see a couple of homework problems. Okay, 1.7. So last time in 1.7 we studied innover. Okay, so bound. I mean open close innover and the bounded unbounded innovers, and then we study how to find the solution set of linear inequality. Okay, and then compound inequality. We study compound inequality. Um, so yeah, so let's see problem number 8. Yeah, we'll see a couple of compound inequality problems because uh, the compound inequality to solve the compound inequality, you need to understand the integral notations and you need to know how to solve the linear inequality too. Okay, so pretty much you have to know everything, okay, to solve the compound inequality in 1.7. Yeah, so see that here, problem number 8, solve the compound inequality. So 2 is greater than 6 minus x, and 5 plus 0.5x is less than 9. So yeah, let's find out solution set. Here, what does that mean, solution set? So the solution set, excuse me, here means that we want to find out numbers, all numbers satisfying both the linear inequalities. Okay, so for example, when x equals let's say x equals maybe I don't know, maybe 5. Okay, for example, let's say x equals 5, then 2 is greater than 6 minus 5. Makes sense, right? Yeah, it must be true, right? And then 0.5 times 5 is less than 9. Yeah, it's true. So 5 is x equals 5. 5 is a solution satisfying both linear inequality, right? So we're gonna find out such a number, a set of such a numbers. So let's see. So here, oh, give me a second. Okay, right there. Okay, so 1.7. Okay, so problem number. Let's see that. So 1.7. Yeah, linear inequalities. Okay. All right. So the homework set, 1.7, and oops, excuse me. Problem number 8. All right. I know it's so blurry, right? Give me a second. Okay. So now what are you gonna do? So yeah, definitely we have to solve two linear inequalities. Okay, 2 is greater than 6 minus x. Okay, and then 0.5 x is less than 9. Okay, so it's not a big deal, right? So I believe that you know how to solve the linear inequalities. Okay, so pretty much similar to the process for solving linear equation, right? So we pretty much isolate x. So I want to get the x on the left hand side alone. So we add x. Okay, we just add x. Then we got the x plus 2 is greater than 6, right? Okay, so now it's greater than, okay, greater than. Then we subtract 2. So subtract 2, then x is greater than 4, right? Okay. So now next one, 0.5x is yeah, x is greater than 4. I'm sorry. So we just, yeah, that's not the answer. We need to figure out the solution set in integral notation. Okay. Then here's number line right there. Okay. So negative infinity and the infinity. Okay. Yeah, you can just directly figure out the integral, I mean solution set in integral notation, but I want to just figure out you know, the inequality in number line to visualize solution set. Okay. So yeah, maybe this is 0 here and this is 4. Okay. So x is greater than 4 means the what? From, see, the gradient, there is no equal sign. So we got to use open number. Open number means we use parenthesis as notation of open number. Open means that the n number is not included. Keep in mind this. So x cannot be 4 because there is no equal sign. So we have to exclude 4 from the solution set. So we gotta use the what open number, I mean parenthesis. So this is 4 to infinity. Okay, that's the, which I told you, the infinity is not a number. Okay, just symbol. Okay, representing huge number that we cannot imagine. So we have to use open 2 here. Okay. So 0.5x is less than 9. Yeah, we need to, well, divide by 0.5, right? Okay. So keep in mind this, the big difference between, linear equation and the linear inequality, in when you deal with a linear inequality, when you divide by or multiply by a negative number, you have to change the inequality, okay? You have to reverse the inequality. Keep in mind that. So divide by 0.5, okay, divide by 0.5, then what happen when you get this 9 or 0.5, which is what? The 18, right? Okay. So x is less than 18. So raise 18. Yeah, less than 18 is right there. I know it's kind of doesn't make sense, but yeah, sorry. Yeah, uh, I didn't expect that this we're gonna get this is such a huge number. So x is less than 18, so there is no equal sign inequality. So we gotta use open, and the less than, right? So all the numbers less than 18 must be solution of that inequality, right? Okay. So x is less than 18, so negative infinity to 18. Okay. So now, okay. So you see the end. Okay. So in mathematically, end can be interpreted as what, intersection. Okay, remember that last time we learned the two type of connector, right? Union and then intersection. Okay, okay, intersection. Okay, so union means that what? So A union B means that the set of all numbers belong to either A or B. Okay, either A or B. So intersection means the what? A intersection B. I mean, what's A? What's a B? A, B, say A, B, a set of numbers. Okay, so A intersection B means the what? The all the numbers, set of all numbers belong to both A and B. Okay, keep in mind this. Right, so keep in mind that. So the end means that intersection. It means that we gotta find out the set of solutions um, belong to both the set of the solution set of this and solution set of this. Okay, so how can you find out the intersection of this solution set and that solution set? 4 comma infinity and then intersected with a negative infinity to 18. How can you do that? We gotta find out common part, I mean overlapping part, which is this, right? Here. Okay. So 4 open to 18 open. Okay. So all the numbers between 4 and 18, except for 4 and 18, okay? Because they're open, right? So all numbers between 4 and 18 must belong to both 4 comma 8, 4 comma infinity and the negative infinity to 18. Okay, so the answer is this. So let me see. Let me type. So let me see. Oh, hmm. Yeah, let's see. You can use click this one. Oh, there's some more there. Yeah, you can click this. Okay, 4 comma 18. Yeah, 4 comma 18. Right. Oh, yeah, something I did wrong. Maybe I made a mistake. Give me a second. see. So here, yeah, we see the here problem. I missed the 5, adding 5 right here. Yeah, I missed that. So I'm gonna add the 5. Yeah, let me let's find the solution set of this one again. Okay. Then adding 5. So we subtract 5, right? So subtracting 5. Okay, so now we add this. Okay. If the 5 is added here, then we subtract 5 first, right? Before dividing by 0.5. Okay. So subtract 5, you're gonna get 0.5x less than 5 minus 5, right? Okay. Sorry, I copied the problem wrong. So let me resolve the problems, not just 0.5x less than 9, but 5 plus 0.5x less than 9. Okay. So then we get 0.5x is less than what? 4, and then divide by 0.5. Okay. 0.5. Then we got x is less than. Still, what we're gonna get same inequality as the original one, okay? Because we didn't divide by negative number. So the 4 divided by 0.5 is what? 8. Okay, so x is less than 8. So give me a second. So the solution set of the second linear inequality must be negative infinity to 8. Okay, so this is 8. 8. So 4 comma 8. Okay, so now next problem. So problem 9. Solve the yeah, same problem. This is also a problem about compound inequality. Okay, so solve the following. Let me share the screen. Solve the following compound inequality. Write the solution set using interval notation and graph it. All right. So see, two linear inequalities are coupled with a connector OR. So we're gonna do this. Connector OR means that we have to find out the union of two solution set. Okay, so this is problem 9. Okay, all right. So problem 9. So 1 minus x is less than 10 plus 2x. Okay, so let me carefully copy the problems. Okay, so 7x. So that so this time I don't want to make a mistake again. Now, so yeah, so what are you going to do? So I'll subtract 2x on both sides, okay? So then we're going to get negative 3x. And then I'll subtract 1 on both sides, so we're going to get 9 on the right-hand side, okay? And then we divide by negative 3. So we're going to get x is greater, right? Because we divide by negative number, then inequality must be reversed. So 9 divided by negative 3 is negative 3, okay? And the right-hand side, we subtract x, we got this 6x. We subtract 6, we're gonna get negative 6, right? Okay. And then we divide by 6, okay? Then we got this, x is greater than negative 1, all right? Now we find our solution set of each linear inequalities in the number line, okay? So negative infinity, infinity, okay? If you are good at finding, a solution set of linear inequality, you don't have to plot the number line, okay? So now is negative 3 and negative 1. Let's say that, okay? X is greater than negative 3. What? That means open to this one, right? Okay. So negative 3 comma infinity. That's the solution set of first linear inequality. And the second linear inequality is what? X is greater than negative 1. So open, because this is greater, right? To infinity, right? So this is going to be negative 1 comma infinity. So we're going to find out what union, right? Negative 3 comma infinity union negative 1 comma infinity. What's this? We want to find out union of these two solution set. I mean, inverse means that what the set of all numbers belong to either here and here, right? But as you can see, the negative 1 comma infinity belong to negative 3 comma infinity, right? So that one, negative 1 comma infinity, belong to negative 3 comma infinity. So negative 1 comma infinity is kind of what intersection of two solution set, two inverse. So the union of those two guys is nothing but what? Negative 3 comma infinity. Okay. So the solution set is what? Negative, well, yeah, is negative 3 comma infinity. Okay. Here's infinity right here. Okay. Oh, sorry, I missed the. Yeah, so this one, negative 3 comma infinity. Now next one, choose the correct graph below. Yeah, so we already, graph the solution set, I mean the answer, right? So which is, I think, negative 3 to infinity, right? And then A. I mean, look at this, A and B. What's the difference between A and B? A, you see, there is open interval. B is closed interval, right? So yeah, choose A, right? Excuse me. Now problem number 10. So it says solve the following absolute value inequality in the right solution set using interval notation and graphic. So now this is the last objective of this section. So we want to study how to solve linear inequality involving absolute value. So uh, okay, so think about this. Do you think objective number 4? Okay, inequality involving what? Absolute value. Let's say ABS. Okay. So yeah, think about this. X absolute value of X is for example, less than 0. Okay. Case 1. Okay. Then let's see. Yeah, let me think about more general case. Less than A, not 0. Okay. A is any real number. Okay. A. Okay. So then this one is equivalent to, I mean, what's the absolute value? Whenever you say absolute value, you have to think about two cases. Okay. So for case 1, the quantity inside the absolute value positive. Case 2, the quantity inside absolute value is negative. Okay. So if x is positive, then we got this. X is less than A, right? X is less than A. What if X is negative? Then we're gonna get negative X is less than A. Is that okay? So this one and this one equivalent. But here's the problem. So we got two linear inequality, right? So this is a compound inequality. The compound inequality, we have to figure out what the connector. I mean, two linear inequalities are connected with and or. Which one is right? Just give me a second. What happened? So now then, give me a second. No, what happened? Hmm. So I want to figure out the connector between two linear inequalities in number line. Okay, so let's say A is right there. Okay, A is right here. The negative X is less than A. That is equivalent to what? X is greater than negative A, right? Because I just multiply by -1 on both sides to make the sign of X to positive, okay? All right, so X is greater than A, X is less than A, and then X is greater than or negative. Negative A is right there. Okay, negative A here. So X is less than or A is this. And then x is greater than a, negative a is this one. Oh, I think open right here, right? Okay. All right. So and then to better understand it, let me plug in a specific number into a. Let's say a is just 5. Okay, it's a 5. The negative a means a negative 5, right? Okay. Then so that means want to find the solution set of that inequality, right? Okay. If we just substitute 5 into a, for example, okay, then think about this. The Let me plug in 0 into here. Then 0 is less than 5. It makes sense, right? So 0 must be solution. What about 6? Plug in 6 right here. Then you're gonna get 6 is less than 5. Doesn't make sense. It's not true. Okay, what if negative 6? Absolute value of negative 6 is 6. Less than 5. It's not true. So all the numbers between negative and a, I mean, in this example, negative 5 to 5, right? All the numbers between negative 5 must be solutions, right? Solutions, I mean. So now, as you can see that this is what overlapping part of two solution set of that inequality, this inequality, right? Okay. So you see now, so now we got the conclusion. So whenever you see once you isolate absolute value term, oh sorry, when you isolate absolute value term, okay, and then inequality is less than, then this can be expressed as a linear inequality with the connector and keep in mind this. Okay, so absolute value of x is less than a. By the way, keep in mind this x does not represent what a single letter x. Okay, that x represent any algebraic expression. So when you deal with when you solve the linear inequality involving absolute value, the very first step is to isolate absolute value in the left hand side. Okay, then you got the linear inequality less than or equals either one. Okay, then that is equivalent to what? This symbol is equivalent. Okay, equivalent to what? Compound inequality. X is less than a, and x is negative x is less than a, which means that x is greater than negative a. Okay. For that inequality, we got this: x is less than or equals a, and x is greater than or equals negative a. Okay. So keep in mind this. So the linear inequality, the involving absolute value is nothing but what? Compound inequality. Okay. So you have to deconvert that inequality to compound inequality and then solve it. So and then that one is equivalent. There is a short expression, especially for this case. Okay, less than or less than equals. That compound inequality can be expressed as like this. Okay, all right. So this is just a short expression of that compound inequality. So x is greater than negative a, and then x is less than a. Two linear inequalities are combined. Okay, so keep in mind this. Next case, what if absolute value of x is greater than a or greater than or equals a? Okay, then so we use definition of the absolute value. So think about two cases. Case one, x is positive. Then we got this: x is greater than a. Okay, and then second case, what if x is a negative number? The negative x is greater than a. Okay, but what x is negative x is greater than a is nothing but what x is less than negative a, right? Okay, so now let's figure out the solution set of these two guys. Okay, so it's negative infinity. Here's infinity. Negative a. Here's a. So for instance, let's say a is 5 again. Okay, so it says negative a means 5. A is 5. Let's say a is 5. So x is greater than a means what? 5 to infinity. Okay, and the a is I mean x is less than negative 5 means that what? Negative infinity to negative 5, right? Open. Okay. So we got negative infinity to negative a, in this case negative 5, and then a to infinity, in this example 5 to infinity, right? So now then what? So as you can see that these two solution set don't have a common part. So the intersection of those two solution set is empty set, right? But by the way, so the that's a side story. But let's focus on finding solution set of that the linear inequality in case of the a equals 5 as example. So then what? So absolute value of x is greater than 5. Then all the number between negative 5 and 5 cannot satisfy that linear inequality, right? Because for example, when you plug in 0 into x, 0 is greater than 5. That doesn't make sense. 0 is not greater than 5. So not only 0, all the numbers between negative 5 and 5 does not satisfy that linear inequality. But all the numbers in that solution, in that number and then this number satisfy this linear inequality. So we can see that that linear inequality is equivalent to what? Compound inequality with connector or. Okay, so keep in mind this. So here, absolute value of x is greater than a, equivalent to, okay, to what? Compound inequality. X is greater than a, or x is less than negative a. Okay, I mean, what if we got greater than y equals, then we're gonna get that compound inequality. X is greater than y equals a, or x is less than y equals negative a. Okay, keep in mind this. So let's run this one. Okay, now what are you gonna do? So yeah, let's see example. Okay, so let's see example in homework set. Okay, so screen. Yeah, you see that here. All right, so absolute value of 8 minus 4x is less than equals 1. So fortunately, you don't have to isolate absolute value term. Okay, so now we're gonna convert that problems to the compound inequality problems. Okay, so let me copy the problems carefully. So this is problem number 10. Okay, in homework set 1.7. So value of 8 minus 4x is less than or equals 1. All right, so now what are you gonna do? So you see that less than or equals. This is the first case. You see that? You see that here, first case. Absolute value of x is less than a, less than or equals a. That's the compound equivalent to compound inequality with the connector and, right? So keep in mind this. Oh, give me a second. It's so blurry. Okay. So now this is equivalent to what? 8 minus 4x is greater than y equals negative 1 and then less than y equals 1, right? Okay. So this is compound inequality. So linear equality 1. Okay. And then the other inequality is coupled. Okay. So this is the short expression of compound inequality with the connector end. Okay. So now we solve the linear inequality 1, linear inequality 2, and then we're going to find out what the intersection of two solution set. Okay. So let's sleep loading. Okay. Now let's see. The first one, negative 1. Okay. That is less than or equals 8 minus 4x. Second inequality, a minus 4x less than or equals 1. Okay. So yeah, so I'll add the 4x, add the 4x. So we got, and then adding 1, okay, then add 1, Yeah. Then we're gonna get 4x on left hand side, and then a plus 1, which is 9, right? Okay. And then we divide by 4, so we got x is less than or equals 9 over 4. Okay. So then we got the number, solution set in number notation is what? Negative infinity to 9 over 4 close, right? There's equal sign right there. The second inequality, let's see, subtract 8, right? Subtract 8. So negative 4x is less than negative 7. And divide by negative 4. Then x is greater than or equals 7 over 4. Okay. Right. So now next one. Okay, so 4. Then what's the solution set in inverse? So we got close 7 over 4 to infinity. Okay. All right, so let's find out intersection of two inverse. So here's a number line, negative infinity to infinity. Okay. So 7 over 4 right here, 7 over 4, 9 over 4 right here. Okay. Okay, definitely you see 9 over 4 is greater than 7 over 4. Why? Because the two guys have the same denominator 4. That means what? The greater, larger, what? The numerator fraction, numerators, the, fraction having the larger numerator gonna be greater than what? The fraction having the smaller numerator, right? So, okay, so now then what? Let's see, negative infinity to 904, which is this. Negative infinity 904, closed. Yeah, so let me use highlighter to represent the solution set. Okay, so 4 over 7 to infinity. Okay, yeah, you can see clearly what the overlapping part here, right? So between 704 and 904, including endpoints and number, and number, that's going to be solution set of that inequality problems. Okay. So the answer is what? 7 over 4 close to 9 over 4 close. Okay. So now, example, see. Okay, let's see problem number 13. Oh, okay, so problem number 13. Okay, write an inequality of the form. So absolute value of x minus a is less than k, or of the form absolute value of x minus a is greater than k, so that the inequality has the following solution set: 6, 12. So give me a second. So which one? Okay, so what? Give me a second. So the key point is, the what the goal in this problem, the goal is to figure out a, and then the what the case, the type of inequality. Is that case one or is that case two? Okay, you learned it. Give me a second. Stop. So we need to figure out a, and then we have to figure out what the what we're gonna get that solution set 6, 12 in this form or in this form, right? So let's see. Let's figure out this. So problem number 13, a little bit difficult, okay, but yeah, I'm gonna help you. So Give me a second. Let's see. Okay. So now the absolute value of x minus a less than k. Okay. Okay. Then we're gonna get this. What? X. Let's see. X minus a is greater than k and then less than k. Is it? Okay. That is equivalent to this one, right? Because you see that. Well, once we isolate absolute value in the left hand side, and the if inequality is less than or less than equals, this is equivalent to what? X minus a is less than k, okay? And then what? X minus a is greater than negative k, right? Okay. So and the connector end. That was the first case. Keep in mind this. First case, right? Okay. Keep in mind this. So now, oh yeah, so I forgot there is a k too. Okay, we have two parameters, a and k, but it's okay. So now we isolate. I mean, this is equivalent to this one. Okay, so I mean, this is short expression of that compound inequality. Keep in mind this, and then we add a. So to isolate x, we're gonna add a. Okay, so we adding a here and three all sides. Okay, that still it works. So we got a minus k left hand side. In the middle side, we're gonna get just x. Okay, we should get x because we want to isolate x. To do that, I just add a. That's why we got x in the middle side. The right hand side is gonna be a plus k. Right? Okay. So what? Let me see. Now let's see. Let's figure out this. Let's find out a and k such that a minus k is a 6 and then a plus k is 12. Right? If there exists such a and k, then yes, x minus a is less than k. That inequality of that form has the solution x 6, 12, right? Okay, so give me a second. Normally it works. Okay, okay. So then, let me see. So yeah, there is a way to solve this to find the a and k for that information in chapter 5. Not too much, but yeah, we'll just try to find out using just try error. Okay, so let's say what if a is yeah, what if a is 9? What if a equals 9 and then k is a 3? If a is 9, k 3, then what? See, 9 minus 3 is a 6, the 9 plus 3 is 12, right? Yeah, so this is the that inequality. This is the form of inequality that has a solution set 6, 12, right? But here's a question: what if what about the other form, x minus absolute x minus a is a greater than k? Okay. So now then, this is equivalent to what? X minus a is greater than k, or x minus a is less than negative k, right? Okay. So it means that means what? X is greater than a plus k, or x is less than a minus k, right? Okay. All right. So from this problem, we figured out that a must be 9, k must be 3. If we apply the same number right there, the a plus k must be 12. The a minus k must be 6, right? So here's a 6, here's a 12. This is a number line, right? Okay. So x is greater than 12 is what? From here, open to infinity, right? The x is less than 6, open here. So we're going to get a complete opposite set of numbers, right? Not 6, 12, inner 6, 12, but is called complement. Okay, complement of inner 6,12. This one and this one, right? So this cannot be the form that has the solution set 6,12. So keep in mind this. So now let's move to 1.2. Okay, so let's see. So let me explain. Let me cover the 1.2 by looking at the textbook. Okay, so 1.2, constructing models and solve problems. So the key point objective is this. For given application problems, construct the linear equation with one variable and solve it. Okay, it's simple, right? So let me move it. So now let me start with example 3. Okay, so solving a problem involving sales tax. So we have seen similar problems in online homework that I covered, right? Remember that? Okay. So now, but you see, okay, Jenny Fong bought a Ford Mustang GT for a total cost of 18,000. Yeah, let me just say 18966. Okay, 18966, including sales tax. If the sales tax rate is 9%, then what amount of tax did she pay? So let me see. Right here. Um, yeah, let me. Yeah, I think you we have to you have to keep watching. Keep watching this example 3 problems, right? So here's when you construct the equation, the normally we set x what problem ask. Okay, but in this problem, uh, the question is to find out excuse me, the amount of the text, right? But in this problem, let's just say set x the price of car x. Okay, so x is the price of car. So give me a second. Okay, so see, yeah, let me just do the solution. Okay, in the textbook, this is really nice. So the price of car right there. Okay, then the amount of sales tax is going to be 0.09x. Right? Why? Because the problem says that sales tax rate is 9%. Okay. Then what the amount of sales tax going to be 9% of x, the price of car, I mean. So 9% of the price of car, which means that 9% times x. But 9% is nothing but 0.09. So we got this. Now but then price of car plus the amount of sales tax, that's going to be total amount, total cost, what she paid, right? So now x plus 0.09x, that must be equal to 18966. 18966 is total cost. See, total cost of 18966. So we solve that equation. Okay. So we simplify left hand side and then divide by 0.09. So we got this. Okay. Well, keep in mind this is not the final answer. Answer is what? We gotta find out the amount of sales tax. Okay. How can you find the amount of sales tax? We multiply the price of a car by 0.09. Okay. So so we multiply 17,400 by 0.09. So we got 1,566. So 1,566 dollars. That's what she paid. Okay. Out of 18,966. Okay. So you got it. So keep in mind this. So the sales tax problem, probably on the test. Keep in mind this. Mm, Now, next one. Give me a second. Yeah. Okay. Now, next one. And then example for next one, solving geometric problems. So sometimes you may, it's really helpful to plot the diagram or geometry, figure or geometry to better understand the problems. Let's see. Okay, so let's see. In 1974, Chinese workers found three pits that contained life-size sculptures of warriors, so which were created to guard the tomb of warrior emperor. Okay, the largest rectangular pit. Okay, so the first sentence is kind of, uh, kind of nothing. Okay, so the actual problem starts from the second sentence. So the largest like rectangular feet, you see, rectangular feet has a length that is 40. Let's see, that has a what? Length that has 40 yards longer than 3 times the width. Okay. So from that one, we can figure out the relationship between length and width of that largest rectangular pit. Okay. And if its parameter is 640 yards, what's a parameter? How can you find a parameter? Parameter is nothing but what? 2 times length plus 2 times width, right? So yeah, so we got the information about the length and width. So now question is this. Here's a question. What are the length and width? Okay. So now let's say x is the width in yard. You can set x, the width in yard, the length in yard, x. Okay, either one just fine. Okay. Then once we set x is the width in yard, then using that information, see that rectangular. By the way, let me draw the rectangular feet first. Okay, just draw a feet right here. You see that? Oops. Can you see that this one? Okay, right here. Let's draw a rectangular feet. And the width set. What? The width in yard x. Okay. Now back to here. Then what? Oh, oops, something wrong. Yeah, it's better. Okay, so you see here the length that has 40 yards longer than 3 times the width. So we need to figure out the mathematical expression of this one. Okay, so the length has, so let me say just L, okay? The length that is 40 yards longer than, it means that we add 40, right? We add 40. Okay, longer than 3 times the width. It means that 3 times x, right? 3 times x. Okay, so 3x plus 40, that's gonna be what? The length, the size of length, right? So you see 3x plus 40 right there. Okay, so now still we need to construct the equations. So so far what we have done is to express the length and width in terms of x, right? So now we see that here, then using this 2 times x plus 2 times 3x plus 40 must be 640 yards because the parameter is 640. Okay, so now let's see here. So 2L plus 2WP, that means L means length, W means width, and the P means parameter. So 2 times 3x plus 40, that's the what? The size of length, right? So expressed in terms of x, okay? 2W means 2x equals 240. So we got the equation of x, linear equation of x. We solve it, we're gonna get 70. Okay, but that's not the answer because the question is to find out the both length and width, right? we just got width, and to find out the length, we plug in 70 into what? Into here. Okay, so 3 times 70 plus 40, which is 250. Okay, so the length 250, width 70, that's the answer. Okay, so move to the next problems. So if you yeah, so if you struggle to understand the problems, please read, look at the solutions in the examples again, okay, after class, okay, and then excuse me. So I'm gonna cover just examples in 1.2, right? So, second. Yeah, and the next one, solving a uniform motion problem. So that problem is related to speed and distance and time. Okay, so let's see right here. Okay, so when you get the this kind of problems involving speed and speed, distance, time, you better just make a table. You can see the solution right here. So just make a table like this. Okay. So and then it's easy. And then yeah, that will that a lot easier to get construct the equation. Okay. So now look at this. A group of hiker from Tulsa hiked down into the Grand Canyon in 3 hours 30 minutes. So coming back up on a trail that was 4 miles shorter. They hiked 2 miles per hour slower, and it took them 1 hour longer. So what was their rate going down? So, all right. So give me a second. So in these problems, we got to use this. Last time I gave you S is equal to. Let me just use my sketch paper. Give me a second. All right. So right here, so S is speed is equal to what? Distance over time, right? Okay. The speed. Okay. This T means time. D means distance. Okay. So let's say here's a Grand Canyon. Let's say G right here, Grand Canyon. Let's say here's Tulsa. Okay, maybe. So let's say the trier. Okay. So a group of hikers from Tulsa hiked down. Maybe Tulsa is up there. Yeah, sorry. Hiked down into the Grand Canyon. Hiked down Grand Canyon. It took 3 hours 30 minutes. So T, that means T is equal to. Let me unify unit. Okay. For time, let me unify the unit as hour. Then 3 hour 30 minutes means 3.5, right? So which is 3.5 hours. Okay. And then the coming back up on a trail that was 4 miles shorter. So when they come back on come back to Tulsa, they use different trail. Okay. Oh, sorry, it should be like this. Sorry, make it confused. And then the distance of that trail. Okay. Let's say just trail A, and then just trail B. Okay. Then they come back on that on a trail that was 4 miles shorter. So if you say this is the uh 4 miles shorter, okay, let me say it's 4 miles shorter. Okay, shorter. So they hiked 2 miles per hour slower, and it took them 1 hour longer when they come back. Okay. Okay. So what was their rate going down? So let's say the rate the rate when they're going down is x. Okay, speed or rate. Let me just say use a rate. Okay, speed doesn't matter, but the text we use a rate. So let me just follow the terminology. Okay, rate x. Okay, then here then give me a second. Now and then other information. So 4 miles shorter, and then they hike 2 You see that? They hiked 2 miles slower. What? 2 miles per hour slower than when they go when they go what? When they were going up, right? So here the rate gonna be when they coming up, the rate gonna be what? X plus 2, right? Is it? Okay. So now, or you can set this one X, then this is gonna be X minus 2. It makes sense. So to match the solution in the textbook, let's say this is X, okay? Then this is gonna be X minus 2, okay? Doesn't matter. It doesn't matter, right? And you got it? Understood that? So then we got rate and time. Then you see that from this formula, we can get this. Distance is equal to speed times time. Okay. So now here, distance is going to be x times 3.5, which is 3.5 times x. And here, distance is going to be what? Give me a second. So give me a second here. Distance is going to be, give me a second. We need to figure out what the time, right? The problem says that they hiked 2 miles per hour slower and it took them 1 hour longer when they come back. So 1 hour longer than what? When they come up. So 4.5 is just time. It's gonna be 4.5 hours, right? So distance is gonna be 4.5 hours times x minus 2. Okay. So now the problem says that what? The trail B must be 4 miles shorter than a distance of trail L, A, right? Okay, it means that 4.5 times x minus 2, that must be equal to what? 3.5x, which is distance of trail A, okay? This is trail B. Trail B is a trail when what they use when they come back, and then trail A is the trail used when they come up. Okay, so now this is equal to this one. 4 miles shorter, it means that minus 4. So we got the equation. We solve it. Okay, I use this one. Distance equals speed times time. Okay, give me a second. Distance is equal to speed times time. Okay, so now I use the figure. Okay, but the definitely you can use the table. You can just make a table what the solution what textbook did. Okay, so now yeah, solving look at the solution in the textbook. You can figure out the answers. The answer is what? Here x is 5. Okay, so now question C, what was the rate going down? That means 5 minus 2 miles per hour, which is 3 miles per hour. So they just hiked up 5 miles per hour, and then when they come back, it was 3 miles per hour rate. Okay. So now next problem, example. Yeah, you can see, let's see example 7 first, okay? So if we have a time, then I'll cover example 6 next time, okay? So now, let's see. And then, see, a beverage producer makes 2 products, orange drink containing 10% orange juice, and then orange delight containing 50% orange juice. Okay, how many gallons of orange delight must be mixed with 300 gallons of orange drink to create a new product containing 40% orange juice? Okay, so this is an example of one of the example of mixture problem. Um, okay, yeah, let's see. First one, let's problem. Okay, yeah, let's the solution. So let X represent number of gallons of orange delight. and make a sketch as in figure 1.5. You see here? Okay. So 300 gallon of give me a second. Excuse me. Uh, this is orange delight, right? Let's see. Orange drink. Okay. So this is orange drink, and that is orange delight. Okay, we want to mix them to get new product of orange juice containing what 40% orange. Okay, so now let's see the table right there. So first, let's figure out the amount of product for drink 300 gallon. Delight we don't know x that's should be determined, right? And then the mixture going to be x plus 300 gallon. So you know the total amount of liquid or mass cannot be changed, right? So for a new product, the amount of new product going to be 3x plus 300 gallon, right? Now let's figure out the percent of orange juice. Orange. The problem says that orange drink contains 10% orange. 10% of a 300 gallon is must be what? 0.1 times 300 gallon. That's the amount of extra amount of orange in the orange drink. 300 gallon orange drink. Okay, and then for the delight, the problem says that what the orange delight contain 50% orange juice. So extra amount of orange in the orange delight, the product, x gallon, I mean, 0.5 times x. And now, what? Then we can figure out the amount of orange. We can express the extra amount of orange in that new product in terms of x, which is 0.4 times x plus 300 gallon. It makes sense, right? 0.4 is what? 40%. X plus 300, that's going to be amount of the product. So what? The 0.4 times x plus 3, this is actual amount of orange juice in the mixture. That must be equal to what? Sum of two oranges. Okay, so we're going to get this. This makes sense, right? So now we solve that equation for x. Okay. So mixture problem or speed, distance, time problems, yeah, is really helpful to, the table is really helpful to understand the problem and the construct the equations. Keep in mind that. Okay. So for the speed, distance, time problems, just make a table. Each column just represent the distance, time, and speed. Rate. Okay. For the mixture problem, amount of liquid, and then percent of the substance. Okay, and the extra amount of substance. Okay, so keep in mind that. And then we go to the next problems. Work problems. All right. So okay. So let's see. Let me just briefly explain this. Okay. And then the I'm gonna go over all homework problems in 1.2 and 1.7 and 1.5 and 1.4. Okay. Next time. So at example 8, work problem. So let's see. Mm, First, you need to read this. Work problems are problems in which people or machines are working together to accomplish a task. So typical situation might have two people painting a house at different rate. Suppose Joe and Frank are painting a house together for 2 hours, and Joe paints at the rate of 1/6 of the house per hour. It means that what? The Joe paints at the rate of 1/6 of the house per hour. That means what? It's gonna take a 6 hour to complete the work, painting an entire house, right? While Frank paints at the rate of 1/3, it means that it's going to take 3 hours to complete the work painting, right? Keep in mind this. So, but keep in mind, look at this. Suppose Joe and Frank are painting house together for 2 hours. So 1/6 times 2, which is 1/3 of the house. This is the number of the amount of work have done. I mean, Joe have done. Okay. So 1/3 of house, Joe did paint for 2 hours, and then 2/3. This is the amount of work have done. I mean, the Frank have done. Okay. So keep in mind this, so you understand this concept. But in the work problem, we always set one. The total amount of work is one. Keep in mind this. So look at the example 8. At the refinery in Port Arthur, engineers use tube pipeline to fill a large tank with crude oil, and the tank could be filled in 36 minutes using the North Dakota pipeline, or in 24 minutes using the New Mexico pipeline. Actually, I solved these problems before, but let me take a look at this again, okay? So now the North Dakota pipeline was turned on, and then 1 minute later, New Mexico pipeline was turned on. Both were left on until the tank was filled. So for how long was the New Mexico pipeline on? So we need to figure out the time took, okay, to fill the tank when both pipeline work together. Okay. So now see, let's make a table, okay, because we need to figure out the rate and time and then work completed, right, for each pipeline. So for New Mexico, the problem says that we'll see New Mexico 24 hours using New Mexico pipeline. So it means that 1/20, 1/24, that's gonna be work rate. Okay. It means that it's gonna take 64 minutes to fill the tank. It means that 1/64, that's gonna be work rate of New Mexico. And then North Dakota, 1/36. Why? The problem says that the tank could be filled in 36 minutes using the North Dakota. So it's going to take 36 minutes to complete the work. When you fill the tank, it means that 1/36 must be the work rate. And then we set what? X, the time to complete, the what? For the New Mexico to complete the work, accomplish work, okay? Here's another things. You see, the North Dakota pipeline was turned on, and then 1 minute later, New Mexico pipeline was turned on. So North Dakota pipeline was turned on first, before 1 minute. Okay, New Mexico pipeline was turned on. So then what? The time for the North Dakota must be x+1, right? And then we're complete gonna be what? Rate times time. 1/24 times x for the New Mexico. And then for North Dakota, 1/36 times x+1. Okay. So now what? Second. Excuse me. So now we sum up since they work together, right? So 1/24 times x plus 1/36 times x+4, that should be 1. I told you here we set set the work, the total amount of work 1. Okay. So this New Mexico worked this much of, oops, yeah, this much of work done, and then North Dakota just have done this much of work done. Okay, so adding them up must be equal to 1. We solve it. Solving that equation for x, so it's 14. It means that this is time. What time for the New Mexico pipeline was turned on. Okay, so all right, so please let me stop here. Okay, so please review all problems examples in 1.2 by yourself. Okay, you definitely need to review. Okay, so excuse me. So that's for today.